6 weeks ago, I came across this fault. The entire ceiling was live. I tried so many things to fix the fault. Tested loads of things, disconnected loads of wires, and several times I thought I'd fixed the problem, but it kept coming back. So today, I'm back to try and finally fix this issue once and for all. We've had thousands of comments from you subscribers about what you think the problem might be. So today, we're gonna test some of your theories live on camera to see if you were right. And make sure you leave a comment on this video if you think you know what the problem is. So our lovely customer Alan here, who you might remember from the previous video, is going to tell us a little bit of an update of what's happened since we were last here. Because I believe you spoke to the neighbour, didn't you?
I spoke to the neighbour because this house is always built at the same time, about 30 years ago, and the same company done everything, so he said he's got no problem at all. I think that another neighbour behind there, so they had a problem, but not a similar, but some electric problem, something simple in the garage, but I don't know what it was. Yeah. I couldn't speak to him.
Yeah. Since I was here last, obviously Lee's done the EICR and he did find that there's been quite a lot of alterations and a few dodgy junction boxes and things like that. So we think it might be something to do with that. Hopefully we'll get to the bottom of this, because I can imagine it might have been worrying you a little bit, has it?
I am. I'm a bit worried because I want to get everything done, because when this is finished I've got the other things to be done. Yeah,
because originally the whole point of this work was to get the ceiling insulated, wasn't it?
That I was thinking of, But once it's done, because it's in the room will be a bit cold, so just see what happens. I'm crying now, it's too cold. Look.
It's not. It's really cold here. It's about 2 degrees. So yeah, we won't keep you in the cold any longer, but hopefully we can get this fault fixed and then you can carry on with the building work here in the garage.
Thank you very much. Thank you very much. Leave everything to your capable hands.
Thank you. Now, one of the things that we're doing today is upgrading this consumer unit to a new modern one. A lot of the circuits don't have RCD protection, which we picked up as something that could do with improving. We have done an EICR a few weeks ago. Lee did that EICR, and he's here with me today doing the remedial work to fix some of the problems that we found on that EICR, because there were quite a few shocking issues that Lee discovered. So I'll hand you over to him and he's going to show you what he found.
So if I go through the cert, we've got some dodgy junctions in the loft, which is where the bathrooms have been refurbed. It's just sort of bare cable and wire goes in the loft, so we'll be getting them properly connected. The downlights in the bathrooms also need re-terminating because they've got single insulation on show. We've got some further investigations. When I was doing R1, R2 on the lighting up here, some of the lights from sort of this point onwards to the end of the house didn't have an R1, R2 reading, and what I think it is the junctions in the loft for the downlights. Some of the earths weren't connected properly, so once I've done them junctions, we'll recheck at the end and we should have our R1, R2. So I'll jump up in the loft, start fixing the things in there, and I'll work my way down.
So I've just done the consumer unit change, everything's upgraded, we've tested it all. Lee's done all the remedial work to fix all of the dodgy things that we found during the EICR. So the question is the ceiling still live or not? Let's take a look. For goodness sake, that is ridiculous. It's literally everywhere. So what else have we done? We've fixed that light. We have replaced the wiring in the garage, so the garage has been completely rewired. The only thing that's left that we think it could be potentially is the feed from the garage to the kitchen. But when Lee was here last, he took all the downlights down. He put his ferret camera in the ceiling trying to look for any junction boxes or anything, because we thought maybe there's a junction box with some wires out, maybe there's a cable that's damaged or something like that. The thing is, the insulation readings all test out okay. It's just really, really bizarre. We're going to read some of your comments and see if there's anything in here that we think might be able to solve the issue. The first comment comes from Stephen Sains 7100. I'm 1 minute 55 in, there's a static, very high impedance charge on the ceiling, likely from a foil barrier that's contacting a live wire somewhere, or even in close proximity. The giveaway for that is a static charge detector, proximity detector flashing, in other words the volt stick, but not the multimeter, which is too low a resistance, even a couple of megohms. As to the source, if indeed it poses a shock hazard, questionable, is challenging to find. In other words, what he's saying is basically that if this ceiling has foil-backed plasterboard, it can act as a large conductive surface, and when a live conductor runs close to it, the AC, the alternating current, creates what's called capacitive coupling, and that non-contact voltage detector, in other words the volt stick, will react to that electromagnetic field. So there's voltage but no current, which basically means it's like static electricity, right? Static electricity can give you a little shock sometimes because it's quite high voltage, but there's no current, so it's completely safe, it's not dangerous. First we need to check if there is actually foil on the back of these plasterboards. So we'll have a look at that. We can do another test with a 2-pole voltage tester, and we can carry out an insulation resistance test between the circuit conductors and the foil backing of the plasterboard if there is indeed foil. So let's take a look. Well, unfortunately, it's not foil backed plasterboard, so that foils that theory, unfortunately. It's just bog standard plasterboard. I'm gonna still do a voltage test with the multimeter anyway, just to see what's going on now since we were here last. But the foil backed idea, unfortunately, is not a goer. Sorry, Stephen. So when we do a voltage test from the ceiling to earth, we get 5.8 volts AC. If I do a DC voltage test, there's nothing. If I do a continuity test, there is nothing. 5 volts on the ceiling is not enough to worry about at all. On the screws, the voltage is a bit higher. It's 23 volts on the screws. So I think the screws, they go straight into the wood. I think maybe there's something with the wood. There's 24 volts on that screw, 29 volts on that screw, 31 volts on that one. So it's actually getting higher as we go this way, and then it goes down to 20. So if anything, if there is damage to a cable in the ceiling, it's around here somewhere. 31 volts is not nothing, you know. It's not touch voltage, but it's close. I think what I might do is just cut some plasterboard out here and just see if there's anything going through this section. And maybe we cut out this bit here as well, just to make sure that there's no damage here. Right, so a little update for you on this. We have been doing some testing with the multimeter just to cover all bases. Let me show you this. First of all, one of the things that we thought is maybe dodgy contact voltage testers, right? So we got 3 different ones, okay? Just to show you, this one, it's live. This one, Fluke, which is the one I used before, it's live. We've also got this mega one that Lee's got, and that one, it goes off before you even touch it, which is crazy. So there's definitely something going on from a contact voltage perspective. Then we got a multimeter. Now, some of you guys told me, oh, you need to be testing with a proper multimeter. You shouldn't just be testing with your GS38 leads or your MFT. So I'm using a proper multimeter, okay? From the earth bar in the consumer unit to various nails. Okay. So we got 20 volts there. This seems to be where the voltage is the highest. And we have found a nail here that's been misnailed, and it's a lot deeper than the others. So we did wonder if maybe that nail, or one of these nails, is going through a cable somehow, or very close to going through a cable. But there's only one way to find out. By the end of this video, we'll have the whole ceiling down. The feed for this circuit, bizarrely, goes this way. This is the feed for this circuit, right? And for those of you who didn't watch the previous episode yet, what I'll show you is when we turn off the lighting circuit here in the garage, in the downstairs, it goes off, right? So it's definitely something to do with that cable, which is this cable here. So we're gonna follow this now. That's interesting. The cables, I found the feed, and it does go along, and then it goes through the joists here, and then it goes along in this void to reach the light there. And I wiggle that moves the light. It doesn't look like there's any damage to this cable where it goes through the joists. I'm just going to check. It looks absolutely fine. So the other theory that somebody had, it was Chris-HY6J. If the plasterboard has any moisture content, it will be coupling the AC from the cable in the ceiling to the surface of the board. A very high impedance though, so it's not dangerous. Moral of the story, throw those voltage sticks in the bin. So why this is plausible is that damp plasterboard becomes slightly conductive, and that will significantly increase what's called capacitive coupling. So a bit like the previous idea with the foil backed, it basically allows the electromagnetic field from the cables to be detected through the plasterboard, even though there's no genuine fault current. So the way to test this is I've bought myself a moisture meter. Okay, so let's see what this moisture meter says. That's interesting. It says that not enough of you have subscribed to the channel who watch our videos regularly. So if you haven't done so yet, hit that subscribe button. If I stick that in there, that's telling me that there's 12.5% moisture in this plasterboard. Let me know in the comments, guys, whether that is high or not, because I don't really know. I'm not an expert on these things, but my gut feeling is it does feel a little bit damp in here. So it could be that that is an issue. So this theory about the moisture, I think it's got legs. You know, it does feel like the plasterboard's a little bit damp. They have suggested that if we were to get a dehumidifier in here and try and dry it out, maybe that would solve the problem. So basically that's the only way to tell whether that is the cause of the problem, is dry the room out and then retest once the room is dry. But that's something that's going to take time. We can't just do that instantly. So we'll keep searching through these comments and see if there's anything else that we think it might be. Now, one of the things that people have mentioned is that, maybe it's a metal stud ceiling. It's not, it's wood. And there is no foil backing on the plasterboard. So there's no metallic parts to like pick up live current in the ceiling, which is one thing that a lot of people thought there might be. It could be that this capacitive coupling thing is an issue, but maybe it's the moisture that's causing it to kind of blow out of proportion in this particular room, because this is the only kind of damp, cool room in the property. Bjorn V78 says, your assumption is wrong there. These non-contact voltage detectors like the Fluke Volt Alert and the generic ones from overseas are advised as 90 volts to 1000 volts AC, but that's not completely true. In fact, these sticks also respond to frequency noise of even 5 volts DC. In a lot of devices, you get these switch mode power supplies, so like chargers, electronic lighting drivers, they all produce high frequency electrical noise. And the non-contact voltage detectors can react to this noise even though there's no hazardous voltage present, which might explain why Lee's one is going crazy even before you touch the ceiling, because it might be more sensitive to that kind of high frequency noise than the other two are. But the only way to really remove that is to isolate every single piece of electronic equipment, just to see if it is a piece of electronic equipment that's putting this noise into the system, and then retest everything. But I just don't really think that's feasible. So we're just in the room above, because when we actually test with the voltage indicator on the wooden joists downstairs, the wooden joists themselves are actually showing voltage with the voltage detector, and the floorboards from below are as well. So we thought we'd just check up here just to see if anything's coming through up here, but nothing is coming through at all on the floorboards on this side or anything. So I think it must be to do with the damp, because obviously this side of the floorboards is nice and dry, and the carpet and everything is obviously a good insulator anyway, and it's nice and dry. But underneath, where it's damp, that's where it seems to be conducting. So if it was one cable that was damaged, one circuit that was a problem, you would just turn that circuit off and the problem would go away. But in this case, it's happening with multiple circuits switched on and off. As long as there's enough circuits on, it's showing the fault, because it seems to be building up the capacitance from multiple cables that are in the ceiling and just inducing that fake kind of voltage into the ceiling boards basically. So we've done some research, and 12% humidity or 12% moisture in plasterboard is definitely not good. It does appear to be much damper than it should be, and I think that's why we're having these conductive capacitance issues. So the good news is it's not dangerous. It is just a bit like static electricity, but it's spreading further than it should, because the moisture in the plasterboard is making the plasterboard conduct that capacitance further. It's a bit like when you rub your arm, right? When you rub the volt stick on your arm, it lights up, or when you go under some big power lines, your hair stands up, because there's a lot of static electricity in the air. There's a big magnetic field. Well, that's what happens if you've got lots of cables running around the place. There's a large magnetic field around those too, and I think that's what's caused this problem. So I hope you've enjoyed this video. If you have, it really helps if you subscribe. We like to share interesting faults on here. In fact, you'll love this one up here. Why not watch that next?